Hello everyone, welcome. So continuing from the last lecture, in last lecture we looked at few of the examples on random variable. We tried to understand that what is random variable, and at the end we saw that a random variable is a function that cannot be multi-valued. What does it mean? It means that if random variable has some input that are the outcome of some experiment, then it cannot map the same outcome to two different value. So it cannot map this one to A and this also maybe A1. So random variable cannot be multi-valued function. Now we will proceed further and we will look more interesting thing about the random variable. Before looking at, let's look at the differences between discrete and what is this continuous random variable. For few of the lectures we will first go through the discrete random variable and later on we will go through the continuous random variable. So the point to observe about the discrete random variable and continuous random variable, we have also the mixed random variable, but the application of that mixed random variable is not too much. Also in our syllabus it is not mentioned about the mixed random variable, so that's we are not going to go through. Before we jump directly onto the discrete random variable, these are the important points regarding discrete random variable and continuous random variable. So let's suppose we have some experiment and there is a associated random variable, there is a associated discrete random variable with that experiment. Let's call that random variable as x, and this is discrete random variable. So the point regarding discrete random variable is that what will be the input to this discrete random variable? The input to this discrete random variable will be outcome of some experiment, right? So we will pick any sample space, we will pick any elements from the sample space, and that will go to the this discrete random variable and it will map somewhere on the real line, right? So the point is that the input to the discrete random variable could be discrete sample space, could be continuous sample space, or even it could be the mixture of both discrete and continuous sample space. Now coming to the continuous random variable, in this case let's suppose we did some experiment and there is a associated random variable, continuous random variable, not only random variable, there is a associated random variable, sorry, there is an associated continuous random variable for that experiment. So the point here is that this random variable cannot accept input that are discrete. Why? So this is a continuous random variable, right? So the output would be anyhow the continuous. Let's suppose we took we did an experiment. Let's suppose we die a roll. So these are the possible outcome. So let's suppose that we put this as an input to this random variable. So this is continuous random variable. So anyhow this random variable is going to map this single value or this discrete value to some continuous value. And what we have learned in last video, that random variable cannot be multi-valued, because if the output to this is continuous, that means we are mapping a single value to some multi-values, right? So this is a contradicting to what we have learned about the random variable. So that is why it cannot be produced from discrete sample space, because of the requirement that all the random variable be single valued function of all sample space points. Okay, now moving forward we will be looking more interesting point about the random variable. So from our last few videos we have seen that a random variable can take different numerical value depending on the outcome of the experiment. And also we have seen that some outcomes are more likely than other. It could be case, right? So similarly, some of the possible numeric value of random variable will be more likely than other. So we will describe this relative likelihoodness in terms of, that is what we are going to call as a probability mass function, in short PMF. So what is this PMF? It is a probability law or probability distribution of random variable x, which gives the probability of different possible numerical values, right? So basically now let's understood this through an example. And before that, this probability mass function has different names. That PMF is also sometimes called the probability law, probability distribution of discrete random variable, right? Okay, let's first of all understood this. So what we are trying to do, let's suppose we have a probabilistic experiment with 4 possible outcome. Let's suppose we have the sample space of and some probabilistic experiment, and in this sample space we have 4 outcomes. Let's suppose this A and B and C and D. So these are the 4 possible outcome of an experiment. And we also have a probability law on the sample space. What is this law? That all these possible outcome are equally likely. So we have total of 4 outcome. So what will be the probability of each outcome? So that will be, if I am saying that all are equally likely, that means all will have the probability of occurrence is 1 divided by 4, right? So that's the assumption regarding our probability law. Now we introduce a random variable. So we have an experiment. Now we can introduce a random variable that will be associated with, or random that will be associated with some experiment. And even we have seen in the first lecture that experiment could have many random variable associated with that, right? So let's suppose we introduce a random variable and we call this random variable as x, right? And let's say it maps. So what we have learned about random variable, we have learned that it is going to take the input from where, from this sample space, right? And it will map somewhere on the real line, right? And since we are talking about the discrete random variable, so it will map to some point on the real line, right? So let's suppose that it maps this A to, so what you do, you will give this input to this random variable, and what it will do, it will simply map this to, let's say, to 5. And how it is mapping, let's not worry about it. We have seen in our very first lecture that we can think this as an abstract object, or even we can think this random variable as an black box. So how it is mapping from this outcome to 5, let's not worry about that, but let's think it as a black box, that it is doing it. So yeah, it is doing it. And let's say that also this outcome, that is B of an experiment, let's say we do the experiment and we got this B, and how this B is getting mapped to, we will have input to this random variable, and let's say it again get mapped to this 5, right? So one more point here, that to two outcomes can be mapped to single point. Even we have seen in our second lecture of random variable that in edge cases we can map all those outcomes to single point, right? So that is the possibility that we can do that. But random variable cannot be multi-valued. What does it mean? Again, I am repeating that we cannot map the one outcome to two different places or to two different value on the real line. Now again we did the experiment, and let's say we got this second, we got the maybe we got this C as an outcome of our experiment, and let's say random variable, this outcome goes to the input as an input to this random variable, and it maps this outcome to somewhere here at 4. And again for this x outcome, that is D, that random variable x, it maps this to somewhere at 3, right? And this will be a real line, and let's say the random variable that are taking the values is small x. So what are the values of random variable that random variable can take is 3, 4 and 5, depending on what, depending on हमने जो भी एक्सपेरिमेंट किया उसका आउटकम क्या है, राइट? अब देखो यहाँ पे पॉइंट क्या है कि मैंने जैसे ही लेक्चर स्टार्ट किया था, when I started this lecture, then I told you very first point is that when we started looking at the probabilities, we talked about the events, right? And I told you that event could be descriptive. I mean to say that maybe we can say event like this: the rolling a die is a event, and event could be also a numeric value, right? जैसे कि मैं ये बोल दूँ कि outcome is 3, right? Or getting 3 is an event, right? So now we are moving towards more generalization so that we can like compact our practical problems in mathematical model so that we can solve complex problem. So with the help of random variable, what we are doing is that you can say now all the events we will have in terms of numerical, right? Now instead of asking in descriptive manner the probability of what will be the probability that I will get maybe some descriptive manner we will ask some probability question, but once we have introduced this random variable, now all the problem will get reduced to numerical problems. I mean to say that now I will be asking that what will the probability that this random variable will take 5, or maybe I will ask that what will be the probability that random variable will be less than equals to 3, that random variable will take the value that will be less than equals to 3. So all those descriptive statements will get reduced to this numerical things. That is what the random variable, that is why we have introduced the concept of this random variable, right? Now here for this our example, this random variable can take any of the 3 possible value, that is 3, 4, 5. So we can think of the event like x is equals to 5, x is equals to 5, right? So what is this event? So go backward. What is this event? So when you are getting this 5, when random variable is taking this value 5, when we have these two elements, the outcome of an experiment is maybe A or maybe B, then we are getting that, then this random variable x is taking value as a 5. So what is this event? If I have to mathematically write this about this event, if I have to write down this mathematically, how I will write that? Let's suppose this W is a whole sample space. Let's call this W as a whole sample space. So whole sample space such that when this random variable takes input any of the outcome and it produces or it gets the value 5, right? So what does this set means? This set means that the set of all outcomes, that is W, the set of all outcome for which random variable outcome is 5, or for which random variable takes value that is 5, right? So what are those? Those are nothing but the outcome A comma B, right? Then moving forward, I can even ask what will be the probability of this event. So you have information about this event. So this event is nothing where random variable is taking the value 5. This event is nothing but this event. So what will be the probability that a random variable x is 5? That will be, what's the probability of getting A or B? That is 1 by 4. So 1 by 4 plus 1 by 4, that is 1 by 2. Now coming to here, this notation. So this is probability. Since we could have, for a single experiment, we can have more random variables associated with that experiment. So we are talking about this random variable x. That is why we have specify here by writing as a subscript that we are talking about the probabilities of random variable x, right? And for what event we are asking the probabilities, or for what value that the random variables takes, we are asking the probability, right? More generally, how we can write this probability notation as like this, that we are talking about the probabilities of some random variable. So in this case we are talking about this random variable x, so that is why I have written it as x, and we will be asking that what will be the probability that random variable will take the value small x, right? So this is nothing but the asking the same question as what will be the probability that random variable, that is capital X, will take some value small x. So more generally, we will be using this notation to denote the probability of the event that random variable x takes a particular value, that is small x. Now with this, I can ask you, like, what will be the probability or how likely that this random variable x will take value 5? Give me some numerical quantity for that. So what you will do, you will calculate the probabilities, right? That same thing, that how likely that the random variable x will take the value 5. How likely, that means you have to find the probability of this, right? And this is nothing, since we are talking about the probability of random variable x, where this little x is nothing, but we are talking about that random variable is taking the value 5, right? What's the probability of that? That is 1 divided by 2, right? So that is the point, that how we have seen in basic probabilities that we have talked about the likelihoodness of these outcome. Similar fashion, we are talking about the likelihoodness of the random variable taking these value in terms of the probability mass function if it is a discrete random variable. You can think this also as a function. So PMF is a function of an argument little x, and for any x it specifies the probability that random variable takes on this particular value. So we can simply think this probability mass function is like a function where it takes argument and tells you about the likelihoodness of the random variable taking some value. We can even plot this PMF on the y-axis. We have this probabilities of random variable taking values. So what will be the probability that random variable will take the value 5? That is 1 by 2, and similarly for 4 and 3, right? So the overall point is that these PMFs are nothing but it shows the likelihoodness, or it tells you about the likelihoodness of a random variable taking some values. So these are just a probabilities law, so we can talk about their properties. So again, this PMF is nothing but the probability. So probability of some random variable taking some value x will be always greater than equals to 0. So these probability mass function or PMF are non-negative, and if you add all those probabilities which random variable is taking, so in this case random variable is taking 5, 4, 3. So what we are doing is we are running the sum over this small little x. So here that will be nothing but probability of 5 plus probability that random variable will take 4 plus probability that random variable will take 3. So that will sum up to 1, right? How you can think this one as, so we have this experiment, right, where the outcome is this A, B and C and D, right? And probability that random variable takes the value 5 is associated with this event, right? So this is one event, and the probability that random variable takes the value 4 that is associated with this event, and the probability that random variable takes the value 3 is associated with this particular event, right? So the probabilities of these three events are the probability of different values of random variable x, right? And if you calculate, that will sum up and it will come up to 1, right? So yeah, that is the two properties. We will do few problems in next video. Thank you.